When it reacts, it forms salt. It forms salt plus that one is water. It means acid react with metal oxide to form salt and water. So next we will discuss acids are corrosive in nature. It means it deteriorates or burns the surface on which they fall. It means when acid falls on an object, then it will corrode it. But does all the acids are corrosive? No. Only the stronger acid, that the mineral acid, hydrochloric acid, concentrate hydrochloric acid, concentrate sulfuric acid, these are corrosive in nature. But the milder acid which we use in our daily life, such as citric acid in case of fruit, such as tartaric acid in case of tamarind, oxalic acid in tomatoes, these are weaker acid. It means the weaker acids are not corrosive, but the stronger acid, the stronger inorganic acids are corrosive in nature. They burn the surface on which they fall. They can also corrode our body parts, our skin. So for that, during laboratory, we should be careful while handling that concentrate mineral acid. We also know that the bases, the stronger bases, they are also corrosive. It means the stronger acid is corrosive, the stronger base is also corrosive. Therefore, while working with them, we should be careful. What we know? All concentrate mineral acid are corrosive in nature. It means they burn the surface on which they fall. Not only about the living, they are going to corrode the living object. They are also going to corrode the inanimate object. If the acid falls on wood, then that acid will burn it. What? The next is that if the acid falls on the surface, it will also corrode the surface. Therefore, the acids are kept in what? Plastic or glass container in our laboratory, because they are quite inert and they are passive towards the action of acid. It means the acid, the stronger acids, the stronger mineral acid corrodes the surface on which they fall. It may be living or non-living. But the plastic and the glass bottles are passive towards the acid. Therefore, they are kept in glass bottle or plastic container. The next thing is what? The plastic and glass is passive towards the action of acid. Therefore, acids are stored in plastic or glass container. Let us discuss one more property of acid, that an acid dissociates in a solution to form hydronium ion. It means, and acids are those substances that protonates is known as acid. It means a substance that has tendency to protonate and form the hydronium ion in the solution is termed as acid. But we should be careful that the alcohol contain hydrogen, the glucose contain hydrogen, but that is not termed as acid. Why? They contain hydrogen and they have more hydrogen in comparison to any acid, mineral acid, which we are discussing. But the hydrogen present in the glucose, the hydrogen present in the alcohol is not dissociated. It means if hydrogen is there, but it will not protonate, then that will not termed as acid. Then what we discussed? We have discussed, and acids are those substances that has tendency to protonate or break to produce hydrogen, and this hydrogen react with water to form what? Hydronium ion. Let us discuss it. Common in all the acids. Let us see. We have hydrochloric acid, H. We have hydrochloric acid, HCl. It dissociate to form H plus Cl minus aqueous. If we have sulfuric acid, H2SO4, it will dissociate to form 2H plus aqueous plus SO4 minus aqueous. To the next, if we have HNO3, nitric acid, it dissociate to form H plus aqueous plus NO3 minus aqueous. If we have phosphoric acid H3PO4, then it will form 3H plus PO4 3 minus aqueous. What we have observed in all these acids, what they do? They dissociate to give what? They dissociate to give protons. This one is proton, not hydrogen. It means an acids are those substances which dissociate to give proton. This proton, H plus, it is aqueous. It means it will react with water to form what? It forms H3O plus. This is termed as hydronium ion. And what we have discussed? We have discussed an acid is a substance that dissociate to liberate proton. Proton means H plus and forms what? Hydronium ion. Hydronium, that is H3O plus. Hydronium ion in the solution. What we have discussed? We have discussed that is common in all the acid. It means they dissociate to liberate proton. See here, HCl dissociate to form H plus. H2SO4 dissociate to form H plus. HNO3 dissociate to form H plus. Phosphoric acid dissociate to form H plus. It means all the acid will dissociate to give protons. It means, and that proton will react with water molecule to form hydronium ion. Then what we have discussed, what we have concluded that an acid is a substance that dissociate to produce proton that will react with water to form hydronium ion. Clear? We have discussed that all the compound that contain hydrogen is not an acid. It means what we have to discuss? All the compounds that contain hydrogen is not acid. How we will know it? Let us discuss. For example, when we take an example of glucose, what we have the molecular formula? C6H12O6. Next to that, we will take alcohol. What is the formula? That is C2H5OH. That is ethanol. What we see here in glucose, it has 12 hydrogen. Glucose contains 12 hydrogen. Alcohol contains 516 hydrogen. It means if they contain hydrogen, can we call them as acid? No. They are not acid. Why? Because they contain hydrogen, but these hydrogens are not protonable. It means that will not dissociate in the solution. Let us check how they are not going to dissociate in the solution. When we dissolve glucose in a beaker containing water, this contains water plus glucose. And when we placed what? We have an apparatus, we have battery, one wire here, the next wire here, attached with a bulb, and check it. When we have such type of apparatus and when we dissolve glucose in water, then we will see that this bulb will not light up. Why? Because the solution which we have taken, it is non-conductor. Why it is non-conductor? It is non-conductor because the glucose does not dissociate in the water to produce ion. And we have discussed that water will become conductor if it contains ion. It hasn't ion because glucose does not dissociate, and hence if it not dissociate, it means it hasn't protonable hydrogen. That's why it is not acid. What we see, this is non-conductor because the glucose does not dissociate in the solution. This indicates that it will not protonate. That is, it will not protonate. Let us take another example. We take a beaker having some water into it. This one is water. When we place two terminals attached with a battery having a bulb, then we see this water is non-conductor because this one is pure. Pure water is non-conductor. But when we add acid into it, such as HCl, then when we add HCl, as soon we are going to add HCl, then this bulb will light up because this solution is conductor. How it is conductor? Because this HCl react with water. This HCl has tendency to protonate. It forms what it forms? It forms H3O plus Cl minus aqueous. Ions are formed, and when this solution contains ions, then it will become conductor. It means from this two information, what we conclude, the presence of only hydrogen is not assures that it is an acid. But what is the condition to being acid? It means it contains proton, and that proton has tendency to dissociate in the solution to form hydronium ion. It means a substance which contains hydrogen, and that hydrogen can be dissociated in the solution to form hydrogen ion, then only and only it can be termed as acid. Let us discuss the next topic, that the acid does not show its acidic behavior in the absence of water. It means if water is not present there, then acid will not show its acidic behavior. It means acid does not show its acidic behavior in absence of water. In order to justify this statement, we will perform one activity. Let us take a test tube. In that test tube, what we will take? We take NaCl. We take NaCl. In this NaCl, what we add? We add concentrate sulfuric acid. On addition of concentrate sulfuric acid, what we do? On addition of concentrate sulfuric acid, then a gas will evolve. Let us know the chemical reaction involved here. It means when NaCl salt react with what? H2SO4, then it will produce Na2SO4. What we see here, when sodium chloride is react with concentrate sulfuric acid, it will produce HCl gas. When HCl gas is formed here, then it will evolve. Which gas? HCl. It will come out of the test tube. In order to check the gas which is evolving, whether it is acidic or base, we know the gas which is evolving here is hydrochloric acid. Then in order to test it, we bring what we bring? A blue litmus paper. We know that concentrate sulfuric acid is drying as well as dehydrating acid. What it means? It means if sulfuric acid is there, then it will absorb the moisture. It will dehydrate it. Right? It will remove the moisture present in a solution or an object. It means the HCl which we are obtaining here is what? Dry HCl. This one is dry HCl. When dry HCl evolved here, this one is dry HCl. Which evolved here, we know it is acid. But when we place a blue litmus paper here, then this dry HCl will not turn the color of this blue litmus paper. Why it is so? Because in this activity shows this is an acid and this one is litmus paper. It is blue. We know an acid turns blue litmus paper to red, but this acid is not going to turn the blue litmus paper to red. It means it will remain as such. To the next one, we will take another litmus paper. We will take another litmus paper here, that is moistened blue litmus paper. It means this one is moisture, it means it contains water, and we see that the color changes to red. What it shows? It shows the dry HCl gas we have, and we have the same paper. One is dry and one is moisture. It is without water. This gas is without water, but this is moisture. It means this HCl is going to turn this litmus paper, which is moisture. It means the HCl is going to show its acidic behavior only and only in the presence of water. What we conclude? Conclusion. Conclusion that an acid shows its acidic behavior only in the presence of water. An acid shows its acidic behavior in the presence of water, which we got from this experiment. Let us discuss strong and weak acid. In class Earth, we have discussed strong and weak acid. By taking that example of class Earth, I will explain you what is strong acid and what is weak acid. Why an acid is termed to be strong and why an acid is termed to be weak. In that example, we have taken two beakers. We are discussing strong acid with weak acid. In that class, we have taken two beakers.